So this is what you call an axial internal combustion engine. And it's called that because the cylinder bores run along the same axis as the main shaft. From the front to the rear, you have this main shaft. And then there's 4 cylinders, one here, one on top, one straight underneath, and then one on the back side. They all run parallel to the crankshaft, or to the output shaft if you want. It's not really a crankshaft. And there's an intake piston that runs down the bore this direction, and an exhaust piston that runs down the bore this direction for each cylinder. And then at the ends, there are 2 big cam plates. The cam plates look like this. This is just an aluminum mock-up one, but there's one at each end of the main shaft, and that the pistons, through their piston extensions and roller wheels, push on. And as the shaft rotates, this cam basically turns back and forth and moves the pistons up towards top dead center and then pulls them back away towards bottom dead center. So one of the things that's kind of cool about the engine with the 2 cams that run the pistons back and forth in the bores, not only can you phase those cams for scavenging purposes, but you also can phase them in a way that changes the torque curve of the engine and the overall effective torque of the engine, because you're changing the relationship of the piston to the shaft. This is a sample of the piston, and the piston has this shape to it, and the opposing piston at the other end of the cylinder has a mirror image, so it would fit like this. And the gap that's created between the 2 is where the spark plug is, and then that's what makes the actual combustion chamber. So this is just a sample. Obviously it's got, rings here, and then it mounts onto an extension that has rollers that connect it to the cam wheels at either end of the output shaft. Here's an example of what the engine will look like from the bottom looking up when it's got the turbochargers installed. So it'll have one turbocharger here, another one here. The supercharger will actually draw in air and blow it through the turbos, and then from the turbos to a heat exchanger into the engine. And there's a bypass valve here to be able to shut off the turbo that feeds the 2 cylinders which have canceling, so that the single turbo feeding the other 2 cylinders can remain boosting the intake air and not have any air leak out the turbo that's no longer functioning. The Supercharger drive assembly is pretty clever, actually. It's 2-speed, and it's 2-speed because these pulleys through this set of pulleys, compared to the end result of the Supercharger, changes depending on whether or not you have this clutch engaged on this shaft or that clutch engaged on this shaft. So if this clutch is engaged, it's driving at this ratio to the blower, right? Think because this is going to be a super turbo where the Supercharger blows into the turbochargers, the Supercharger is always going to have to run, and particularly because it's 2-stroke. It's difficult to get the exhaust gas to find the way out on a 2-stroke without something forcing it to do so, which is what the Supercharger is about in this case. Now, this thing is a 2-stroke, but actually it has an oil pump which feeds pressurized oil to its bearings, and it also feeds oil in to the pistons for cooling. So unlike a traditional 2-stroke where you have to mix oil with the fuel, this will run on regular gasoline, not mixed, and this oil pump right here will feed oil to all the essential parts of the engine that require it, lubrication for, again, cooling on the pistons and some of the slides, and also all the bearings that are connected to the shafts that need oil delivered to them. Now, all told, this engine weighs in at about 300 pounds with everything you see sitting on this bench, but it's also been over-engineered. This is an experimental design, and everything's made way bigger and way heavier than it needs to be by the calculations, just to ensure that they don't have any problems with this first engine. They've been working on the design for a long time. They over-engineered it, but it can be built lighter than this. So we're looking at about somewhere around, a finished product is estimated to be about 1 horsepower per pound. So the air path on this is relatively straightforward here. It's obviously into the air filter here, through the drive-by-wire throttle body there. Potential bypass here around the supercharger, which really will probably be bypassing from the supercharger back to the inlet so that we can keep it from making boost at an idle if we need to. And then out of the supercharger into the loop, into the pseudo intake manifold, or what I'm calling the intake manifold. So this piece goes all the way around, front to back, and then it feeds these little runners, if you want. There's 4 of them, and that's where the 2 injectors are that go down into each cylinder. So there's one on the top, that's number 1, then going the other way around, it's 2, 3's on the dead bottom, and then this is 4 over here. There we have manifold pressure, fuel pressure regulator reference, one of my port temp sensors here. So this is in, and then it spreads out and goes around to feed the rest of the engine. Exhaust wise, it's super simple. Once again, on each cylinder, there's an exhaust port. There's actually like multiple ports around the bore. They go into sort of an annular groove that feeds this channel, lets the exhaust out here to the pipe. Then obviously we have a connection to the other exhaust, and then just simply out the back. The deactivating cylinders, which would be cylinders 2 and cylinders 4, have a deactivating valve, a flapper valve, if you want. It's like a throttle blade, almost like a drive-by-wire motor. It's just not controlled by position. It's either on or off. So it goes fully open or fully closed. And then it has the same kind of control here, running a plate on the intake. So when deactivation happens, it turns off the injector so it doesn't spray fuel, and it closes off the intake port completely and closes off the exhaust port. That way, nothing can come in or out of the cylinder, and it's just cycling back and forth with, basically no air moving through it. This is the guy that's got us waiting at the moment. This is a hydraulic starter motor. So we're waiting for the controller to show up. It's being shipped, and we're waiting for it to arrive in town so we can go pick it up and finally put power to the thing and make the engine spin around some way other than by hand or with a wrench. So that's currently what's got us held up. We've got a few more wiring things to finish up. Worked all day on that while we're waiting for this thing to arrive. And it's now, 5:30, and it was supposed to be here. So hopefully this shows up. As you can imagine, something like this might be something you dream up one night, but it doesn't turn into what it is now just by, happenstance. This is 3.5 years worth of documentation. There's 2 of these manuals, and they literally go over every facet of the engine, from design. Everything's drawn up in 3D. Everything's had FEA done to it. I mean, they spent some serious effort engineering this thing over the last 3 years, and then actually producing the parts that we see here. As you can guess, a project like this requires some pretty custom stuff to make it work. So this is a lot of what I've been doing is, modifying inputs and changing outputs to the M1 142 control strategy using M1 build. So we're able to actually write specific software for the needs of this engine if we need it to control things. Like, for example, I'm compiling some changes I've made to the deactivation strategy. So it's things like that that have to take place, as well as wiring sensor inputs and outputs and controls and all of that kind of stuff, just to be able to get to the point where we're ready to try and start the engine. And we're getting closer, but again, we're waiting for that hydraulic starter controller to come. So the original intention for the engine is aircraft or like drone usage, but in reality, it could do anything. It could be adapted to marine. It could be any kind of an engine that someone could see the use for, or let me say it, the engine could be used in any application someone could see a use for. While we were waiting, there's actually no direct or definitive TDC indicator mark on the engine. To put it at TDC, we basically looked through the plug hole and lined up the 2 pistons as they approached each other. Well, normally I would do my tried and true method of putting the one spark plug only in number 1, then crank the engine, and then do a capture of the crank trigger with my 60-2 crank trigger on it. Watch the amplitude of the voltage waveform that comes from the sensor, and you can tell where compression is on number 1, because as the crankshaft speed slows down, coming up on compression, the voltage peak to peak output on the crank sensor gets really small. So the smallest one will be near TDC, And that'll give you a reference within 6 degrees with a 60-2. The problem is we don't have a starter motor. So in order to figure out where TDC was, it was a combination of look through the plug hole and turn the crankshaft back and forth with your finger in the plug hole to feel when it quits making pressure. I also needed a way to know when the intake port's open. So the only way I could think of to verify when the port's open was to take the spark plug out, put a compression gauge hose in and blow air into the cylinder while you turn the crankshaft. Put your ear over the inlet to the intake and listen for when it uncovers the intake port and squirts air out of it, so you have some idea of where the intake port gets uncovered on the intake stroke and where it gets covered up on the compression stroke, so you have an idea where to spray the injector in time compared to the crankshaft. If we were to look down with the intake manifold, or want the runner removed, let's say that way, there's an annulus I was talking about. The exhaust has something similar. This is how all the air gets into the cylinder through all these transfer ports, if you want, on either end of the cylinder. There's an intake end and an exhaust end. Once the pistons move to bottom dead center, they uncover the 2 ports. The timing of the 2 ports is based on those cams. So those cams at either end of the engine can have specific shapes based on whether they're intake cams or exhaust cams. And then also their phasing in relation to each other changes how fast or at what time a particular piston moves away from top dead center towards bottom dead center. So for example, the exhaust cam has a different profile that moves the exhaust side piston at a different rate than the intake one does in order to control the cross flow, or let's say the scavenging effect on the exhaust stroke. So one of the things that's kind of cool about the engine with the 2 cams that run the pistons back and forth in the bores, not only can you phase those cams for scavenging purposes, but you also can phase them in a way that changes the torque curve of the engine and the overall effective torque of the engine, because you're changing the relationship of the piston to the shaft. So after all day's worth of waiting for this guy to arrive, which when it showed up, it didn't have any wires, any control box, no fluid, the motor wasn't hooked up. And like always, the motor is supposed to be 110 volt, turns out it's 220. So that's why we had to string this cord in through the garage into where the dryer is in the house to get 220, because obviously it's the only place there's 220 in the house here. And in the end, the plug doesn't match the wall, so we still can't power it up. And not only that, the hydraulic fittings are the wrong size. It's just like a race car. This is the deactivation control, servo control. Let's see, there's the switch that tells it to deactivate or activate. That little timeout value that says 1.0 ratio, when that goes to 0, it's moved the servo all the way one direction, and then it turns the output off. That simple little control took 3 hours and 5 minutes to figure out how to program. It took me 3 hours to monkey around with it. It took me 5 minutes to call my buddy Oscar Zelaya from Zelaya Brothers and have him correct the code I had wrong to fix it. Sometimes it's better to be not so complicated.